Hello, I just wanted to go over a little bit in section 6.2 because our resources start at chapter 7 and we had a couple more examples in 6.2 to go over. So as a reminder, 6.2 was on the binomial probability distribution, and the binomial distribution is a discrete probability distribution that describes probabilities for experiments with two disjoint outcomes. So there are criteria that have to be met to be a binomial experiment. And we have them filled out here, but I'm going to give you the mnemonic device that I have that makes it easy to remember. So we have RB, which means that we are going to be binomial, which means that we have two outcomes: success and failure. Okay, so we have two disjoint outcomes, success or failure. Then we have I, and that's going to be independent trials. Okay, so trials are independent, which means that the outcome of one trial will not affect the outcome of other trials. Then we have N, which is the set number of trials. Okay. Experiments are performed a set number of times. Each repetition is called a trial. And then N, there's the probability of success is the same for each trial. Okay, the probability of success is the same for each trial. So here we have our B, I, and S bins, which corresponds to the binomial distribution. Okay, so we had a couple of examples to go over. So we're going to skip down to the examples. Okay. In these examples, we're going to be dealing with these inequality symbols likely. So we could have at least, or no less than, or greater than or equal to is going to be this symbol. Okay, it's very important to know what symbol it's actually indicating, because that's going to indicate it's going to affect the probability of these different problems. Okay, so going through and seeing which ones correspond to which symbol is going to be useful. Okay, so a quiz has 5 multiple choice A, B, C, and D questions. You're going to guess on all 5 questions. Construct the binomial probability distribution. Okay, so you got to see that this is a binomial distribution. B, because we have 2 outcomes. We get it right or wrong. Okay, then we had our I, and it's going to be independent trials. If we get 1 right or get 1 wrong, it doesn't affect next one. So our next problem isn't affected on whether we got the previous one correct or not. N is set number of trials. And that's going to be, here we had 5 questions that we looked at. And S, the probability of success, which in this case is being right, is the same for each problem because all problems have 4 options. So it's going to be 1 out of 4 or 0.25, and that's also written as small p. Okay, so what we want is to figure out what is the probability that a student guesses on all 5 questions and gets fewer than 3 correct. Okay, that's what our question is. We want to know what that answer is. So we have a formula that we can use to figure these things out. but we're going to be using our calculator function. So on your calculator, you have two functions, binom PDF and binom CDF. Okay? So all that's different here is P and C. So we are going to be looking at, we have a binomial PDF. It's for phrases that are exactly. Okay, so it would be like the probability that we are exactly 3 correct. Okay, binomial CDF, that C stands for cumulative, and to be cumulative, it's at this point in everything previous. So it would be probability of X less than or equal to 3. So it would be all the problems that are 3 or fewer. Okay, so before we go through and do B, which neither one of these are that scenario, let's go through and figure out the probability X equals 3 exactly. Okay, so because we want to know that we're going to get 3 exactly correct out of our guesses, then we're going to be using our binom PDF. Okay, so let's get our calculator open. Okay, and to get this binomial distribution function, you're going to go through this blue button that says distributions. You go second vars to get there, and you scroll down to find the binom PDF. Okay, our number of trials is how many problems do we have? We have 5. The probability of success is my P, that's 0.25. The X value is how many we're going to get right, and here we want to know that it's exactly 3 correct. Then we paste. If you have a TI-83 where it doesn't have the prompts, this one is your set number of trials, this one is your probability of success, and this one is how many you got right. Okay, so if you go through and you push enter on this, you will get 0.0879. So now we have to go through and think about how we can utilize these two functions, which are the only two functions that we have, to make it what we want it to be. Okay, so let's think about what it means to be fewer than 3. So if we can get 0 correct, we can get 1 correct, we can get 2 correct, 3 correct, 4 correct, or all 5 correct. Okay, being fewer than 3 correct would be getting 2, 1, or 0 correct. Okay, so really this is the exact same as probability of X less than or equal to 2, because being fewer than 3 is 2 or fewer, right? And so now it looks just like our cumulative requirement because we have the right inequality symbol. And so we now use the binom CDF because we have the correct inequality symbol. And we come back and we go to second vars and go down to find the binom CDF. Enter the number of trials. We still have 5 problems. Probability of success is still 1/4. My X value is going to be what is actually in the inequality that has the less than or equal symbol. Okay, so we're going to have to put our 2 there. And we're going to get 0.8 0.965. Okay, and again, my inputs are going to be the number of trials, probability of success, and this number that we are equal to or less than. Okay, if you went through and you did the probability that exactly 2, probability of exactly 1 correct, and probability of exactly 0 correct, and added those together, which you would find those by doing the PDF if you added these 3 together in the same way that we did the x equaling exactly 3, but we did it exactly 0, exactly 1, and exactly 2, and you added those together, you would get the same number. Okay? So interpretation of this is in 100 repetitions, so you take this number 0.8965 and times it by 100. And you round to the nearest integer is about 90. So about, in 100 repetition of this experiment, fewer than 3 questions would be expected to be correct about 90 times. So if you went through and you took 100 different quizzes that had 5 problems, that had 4 options per question, and you guessed every single time, you'd expect that about 90 of them had fewer than 3 correct, if it was purely by guessing. Okay? Kind of dissuades you against guessing, right? Okay, so now let's go through and say the probability that x, that's the number that is correct, is at least 4 correct. So at least 4 correct. You come up here and look at our symbols. At least means greater than or equal. Okay, so again, we can still get 0 correct, 1 correct, 2 correct, 3 correct, 4 correct, or 5 correct. At least 4 correct is going to be those two. But again, we only have the binomial PDF and the binomial CDF functions on our calculator. So you got to figure out how to utilize those to get our answers. Okay, this isn't the symbol that we need to have to be able to use the binomial CDF. So you got to figure out how we can use this. Okay, so the probability that x is greater than or equal to 4 is going to be 1 minus probability that x is less than or equal to 3. Okay, because if x equaled 3 or fewer, and to the probability of that, it would be these different outcomes. But remember, probabilities have to add up to 1, so these probabilities plus these probabilities are going to equal to 1. So if I want only the 4 and 5 probabilities, I gotta take them away from, take 3 and fewer away from 1. Okay? So then I'm gonna get 1 minus binomial CDF. My number of trials is 5. Probability of success is 20.25. And this number that's with the symbol of x is 3, so I go through and do that. So the binomial CDF, the binomial CDF, I have 5 trials, 0.25 probability. My x is going to be 3 in this case because my 3 is what is with my less than or equal symbol. And I get the answer of 0.94375, and I take that away from 1. If you want to just go through and highlight the one above it and push enter, you can do that for anything that you see above here. You just push enter after you highlight it, and it will copy it down for you. Okay, so you're going to get the answer of being 0.156, 0.0156. So in 100 repetitions of this experiment, getting at least 4 questions to be correct would happen about 2 times. Because again, to get that number 2, we just take this number, that's our probability, and times it by 100, because we did the experiment 100 different times. And that rounds to 2. Okay, so the mean standard deviation, these have different formulas. The mean is NP, and the standard deviation is NP times 1 minus P, all under the square root. Okay, so N is the number of trials. So we have 5. My P is the probability of success, 0.25. And 1 minus 0.25 would be the probability of a failure. Okay, so we have the square root of 5 times this 0.25 times 0.75, and you go through and you do that. You have the square root of 5 times 0.25 times 0.75. If you go through and write 1 minus 0.25, you need to use the parentheses, by the way. And so this ends up being 0.97. And the mean is going to be the number that I took, which is 5 times 0.25. And get 1.25. So this means that if I did this experiment many different times, of 5 problems that I guessed on, each problem had 4 answers, I was guessing on them, then I did that many times, and I got how many I got correct, and I added up them, all those ending scores, and divided by how many test times I took that test, my average would be about 1.25. Okay, similarly, that's going to have a standard deviation of all those different values that I guessed all those tests on, and that'll be about 0.92. Okay. Let's do one more experiment. Let's do this last one because it's a little bit more on topic for our world today. So, according to a study done, the probability of a randomly selected individual will cover, that's supposed to be cover, his or her mouth when sneezing is 0.267. Suppose you sit on a bench in a mall and observe people's habits as they sneeze. Okay, so first let's go through and make sure this is a probability, a binomial probability. So, is this binomial? Are there 2 outcomes? What are these 2 outcomes? That they cover or not their mouth? Are they independent? If one person covers their mouth, then that's not going to affect the next person covering their mouth or not. Okay? Is it a set number of trials? Okay? Once you read A, it says that we have 10 observed people, and you want to see if they are doing. So my N is, in this case, 10. And my S, probability of success, which in this case, probability of cover, is going to be 0.267. Okay, so that one's also satisfied. Okay, so now we have the probability that, what is the probability that among 10 randomly observed individuals, exactly 4 do not cover their mouth? Okay, so first of all, you got to think about what symbol does this problem indicate? The probability that exactly 4 people cover their mouth, because X, remember, is the number that cover. Okay? N is the number of trials. P is the probability of success. Okay? So we have this situation, you're like, okay, cool. So if I have that inequality, do I use binomial PDF or binomial CDF? Okay, so remember, we'll go up here into our little notes. In the margin, I said binomial PDF for when it says exactly and we have an equality in my probability symbol. Okay, so this is going to be a binomial PDF. Okay, remember, it's going to be the number of trials, the probability of success, and how many successes we actually wanted. So in this case, my number of trials is 10. Probability of success is 0.267. How many I want to see exactly is going to be 4. And you should notice that if you do your bins, you basically figure out what goes at each of these spots. Okay, so let's go through and do it real quick. So we have second bars. You come down to the binomial PDF. Our number of trials was 10. Probability of success was 0.267, I believe. The X value was 4, because we wanted exactly 4 to cover their mouth in this experiment. You go through and you push enter, and you get 0.1655. 0.1655. So let's interpret this. So that means that in 100 trials of this experiment, the probability, no, the number of people to cover their mouth the number of people to cover their mouth out of 10 being 4. Okay, in 100 trials of this experiment, 4 people, sorry, this is not working as well as I wanted to. My phrasing, in 100 trials of the experiment, 4 people will cover their mouths out of 10 people about, multiply this number by 100 17 times. Okay. So let's go through and do this. What is the probability that among 10 randomly observed individuals, fewer than 3 do not cover their mouth? So remember, we can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people cover their mouth, right? So we want fewer than 3. And I actually recommend that you draw this little number line because it will help you to figure out how you can use the binomial CDF. Okay, so I want fewer than 3, and that's the same thing as probability that you have 2 or fewer. And now we have the right inequality, so now we can use the binomial CDF with the inputs of NP and X. So we're going to have binomial CDF. My N in this case is 10. My P was 0.267, I believe, from the problem. And X is this number here that is with the symbol less than or equal that we need for the binomial CDF. So it's going to be 2. Okay. So we'll go through and go to binomial CDF. Oh, dang it. The computer has a little bit of a lag on it, so I pushed it too many times. Okay, binomial CDF. My number of trials was 10. My P was 0.267. X value again was 2. So I paste it. And the answer, as you can see, and I'll probably restart this recording a little bit, is 0.4752. So we have 0.4572 for that answer. Okay, so to be surprised, that would be that it would be unusual. And to be unusual, you have to be less than 5%. So if after observing 10 individuals, fewer than half covered it, so a probability that X is less than 5, if you go through and do this, you're going to get the binomial CDF, but it's going to be the binomial CDF of, remember, it's going to be fewer than 5 is those, so it's going to be the probability that X is less than or equal to 4. You have the binomial CDF of my N, which was 10, my P, which is 0.267, and my 4 is fewer than half. You go through and you do this. I'm just going to redo the answer real quick and change this to a 4 instead. And I get 0.9004. Which is not less than 5%, it's 90%, so I would be not surprised. And apparently everything is going crazy right now, so I'm going to stop this recording. Hopefully I'll figure it out before tomorrow or Thursday when I'm running a big thing. Anyways, hopefully that will help you. If you have more questions, then send me an email.